Question 1. We have 3 to the power 5 multiplied by 3 to the power 4, all divided by 3 squared. Well, that's the same as 3 to the power, well, we add the powers here under multiplication, so that's 3 to the power 9 divided by 3 squared. And then when we're dividing, what we do to the powers then is we take them away. So we'll have 3 to the power 9 minus 2, and that is 3 to the power 7. Part B, write down the value of 12 to the power 0. Well, that's just going to be 1, because anything to the power 0 is always 1. Let's have a look at part C. It says, write down the value of 3 to the power negative 2. Well, the negative sign here means that you have to find the reciprocal of the base, this being the base here. So this would be the same as 1 over 3 squared. And 3 squared is just 9, so it's going to be 1/9. The other way of looking at this is you can say it's 3 to the power negative 1 times 2, which is the same as 3 to the power of 2 times negative 1. And you can say 3 to the power 2, that's 9, and then you've got the negative 1 left. Because I don't know if you know about the rules of indices here, but if you've got a to the power bc, that's the same as a to the power b to the power c. Don't get mixed up with this one where you've got a to the power b times a to the power c. That is not equal to a to the bc. Remember part A, you add them. It'll be a to the power b plus c. So coming back to this, you'd have 9 to the power negative 1, which is the reciprocal of 9. So it's 1/9. Question 2. We're given the dimensions of a fish tank, and that's 50 centimetres by 32 by 20. And it says the tank is 3/4 full of water and sand. And it says the ratio of the volume to water to the volume of sand is 5 to 1. We've got to work out the number of litres. So first of all, let's remember that 1,000 centimetre cubes is 1 litre. Let's not get that wrong. So let's have a look at the question. Let's work out the total capacity. So the total capacity of the tank, that would be 20 by 32 by 50. Well, 20 times 50 is 1,000 times the 32. That gives 32,000 centimetre cubes, which is 32 litres. It says the tank is only 3/4 full, so 3/4 of 32, well, 4's into 32 is 8, 3/8 are 24, so it's 24 litres. Now, in terms of the ratio, we have 5 and 1, which is 6 parts. So if we do 24 divided by 6, that gives us 4 litres for each part. We want to work out how much of the water is in the tank, and the water was 5 of those parts. So 5 times 4, that gives 20 litres of water. Question 3. In a sale, the price of a cooker is reduced by 50%. At the end of the sale price of the cooker is increased by 50%, and Betty says that the cooker is now the same price as it was before the sale. Well, one way of explaining this, and I do this to students sometimes, is if you think of a whole glass of water, and I'll split this into quarters here. If you poured out half the glass of water, then you'd be left with just half a glass. So I'll do the same scale, and the water would only come up to here. So that's like reducing it by 50%. But then if you increased what you had, i.e. half a glass, by 50%, you'd only be adding half as much to it, which would only bring it back up to the 3/4 level. So if you were to increase that by 50%, you'd be left with, let's do the scale, you'd be left with the 3/4 mark. So that's one visual way of explaining the answer. Another way is you could say, let's start with £10. If I reduce £10 by 50%, then I'll be left with £5. And if I increase £5 by 50%, then I'll be left with £7.50. The last way that I will do here is to say that if you had, for example, X, your starting price of your cooker, and you reduced it by 50%, you just times it by 0.5 as the multiplier, and you would get 0.5x, or if you prefer fractions, because it's not a calculator paper, you would say half x, or x over 2. But then if you took your half x, or your 0.5x, and you increased it by 50%, to increase something by 50%, you can just times it by 1.5. And if you're not sure about that, then look at it as 1 plus 0.5. When you multiply this bracket, you'll have 1 times x, which is what you started with, the price of the cooker, for example, and if you times it by 0.5 and added it to what you had before, you would end up with your original plus half as much, which gives you 1.5x. So another way of looking at it is to say, if you then had your middle glass of water, or your cooker that had already been reduced by 50%, and you increased it by 50% by timesing by 1.5, well, you wouldn't get back to x. You'd have 0.75x or 3/4x. If you don't like timesing with decimals, you can just say that's a half x times 1.5, which is 3 over 2, and then just times these out. 1 times 3, that just gives you 3x over 2 times 2, which is 4, which is 3/4x. But the thing to realise is 3/4x is not where you started. So quite a complicated question, but you would get marks for just using a nice simple example like money, and I think you would definitely get marks for doing something about a glass of water. But the algebraic approach, I guess, is another option. Question 4. In this diagram of the kite, we know that these two angles will be the same because these two sides here are the same and these two sides here are the same. So we can say that 3x plus 10 equals 5 lots of x minus 10. That gives us 3x plus 10 equals 5x minus 50. I'll get the x's on this side, so take 3x from both sides to get rid of this 3x here, and we'd have 10 equals 2x minus 50. Add 50 to both sides, and we'd have 60 equals 2x. Divide both sides by 2, or halve both sides, and x would be 30. Now, if x is 30, that makes this angle 3 30s, or 90 plus 10 is 100. And it makes this one 30 minus 10 is 20 times 5, which is 100. I'm not quite sure why I did that because they're the same, so they're 100. And then we know that angles in a quad sum to 360 because it's two triangles worth, triangle 1 and triangle 2. So we know that 110 plus y, which is this angle plus this one, plus the 2 lots of the 100 that we've already found, that must make 360. So simplifying here, we have 310 plus something equals 360. Well, you can see what that something is just by looking, and that y would be 50 degrees. So x is 30 degrees and y is 50 degrees, and that's what we wanted, y. Question 5. we have 3x minus 2y equals negative 5, and 2x minus 4y equals 2. I'll call this equation A and equation B here. You don't have to do this in the exam, but it's sometimes a good idea. If I double the top equation, then I would have 6x minus 4y equals minus 10, and I'll call that C. I'll write out B underneath exactly the same. Now, can you notice here that the coefficient here is negative 4 and the coefficient here is negative 4? The best way I think of actually finding x and y is to make them cancel each other out when you add. I always add the equations together, I never take them away. So I'm just going to times one of the equations by negative 1. It really doesn't matter which one. So I'm going to times this one by negative 1. And then I'm just going to add C and B together. So I'll have negative 6x plus 2x, which is minus 4x. These cancel each other out, that was the idea. And then I've got 10 and 2 is 12. So negative 4 times something is 12. Well, that something is going to be negative 3, isn't it? So x is negative 3, and then I can just simply substitute into B or A. It doesn't really matter. Let's have a look. I think I'll do it in A. So we sub in A, and we'd have 3 lots of negative 3, because that's what x was, minus 2y equals negative 5, then gives me negative 9 minus 2y equals negative 5. Again, if you don't like the look of that, just times everything through by negative 1, i.e. times both sides by negative 1. And write it out again so it looks clearer. You don't need to write these add signs here. And so you can take 9 from both sides now, and you'd have 2y is 5 minus 9, which is negative 4, halve both sides, y is negative 2. So x is negative 3 and y is negative 2 is the coordinate in space where these two lines intersect. Question 6. There's two approaches here to finding the interior angles of an octagon. One is that you can just look at a centre angle, like so. Know that that's 360 divided by 8. And 360 divided by 8 is 180 divided by 4, which is 90 divided by 2, which is 45 degrees. So once you've worked out this angle here to be 45 degrees, you know that these two base angles are the same because it's isosceles, and we know they must add up to 135 each. But then the same issue would be for all of the others, so they'd all be the same. So if these two added up to 135, then this angle here must be 135. So that's how you could work out this part here and this part here. So they're both 135 degrees each. Alternatively, you could work out those angles by saying the interior angles of a polygon add up to, and you can use the formula n minus 2 times 180. In this case, n is 8, so we'd have 8 minus 2 times 180, which is 6 times 180. And 180 times 6, that's 48, 6 and 4 is 10, that's 1080, but we've got 8 of those angles, haven't we, because there's 8 vertices, so we can do 1080 divided by 8 is 540 over 4, which is 270 over 2, which gives us 135. So I just wanted to explain that a little bit, because some people think, well, I'm just going to use the formula, and some people might just want to use the centre angle and deduce it from the isosceles triangle they've created. So we know that ADJ is a straight line, and we're told that angle BAD, this one here, and angle BAD, which is this angle here, this one, and angle CDA, i.e. this one, are the same, we've got to show that angle CDJ, and I'll just draw it in. Let's have it in this colour here. We want to find that one. We want to show that it is 135. Well, we know that angle BAD and CDA were the same, and we know that angles in a quad sum to 360 degrees, and as we've got 135 and 135 already, that makes 270. That leaves 90 degrees to be shared equally between angle BAD and angle CDA, because we're told they're equal. So these are 45 here. And then, yes, we can see now what the angle here is going to be, because we know that angles on a straight line add up to 180. And so we can just write our last little bit of explanation here. Let's make that fit there. So we can say that, let me just neaten this up a little bit. So we can say that angles on a straight line sum to 180, therefore angle CDJ equals 135 degrees. So you have to write your explanation, so sorry if that takes a little bit of time, but you've got no calculator in this particular paper, so show all your workings and, give these questions a good try. As I've enlarged some of this, some of the angles have popped out from where they should be, but I hope you followed what I've done there. Question 7. We have to write 0.00549 in standard form. Well, we're looking for a number between 1 and 10 to begin with. So we can see 5.49. And what we've got to say to ourselves is, what do we do to 5.49 to get to 0.00549? Well, we'd have to divide by 10 once, twice, 3 times. So we know it's something to do with 10. And if we want to divide by 10, that's like dividing by 10 once, twice, 3 times, which is 10 to the minus 3. So if we do 5.49 times 10 to the minus 3, that's exactly the same as doing this, which is the same as dividing 5.49 by 10 3 times. So that would be the standard form answer for part A. Part B, we want 8 times 10 cubed all squared. Well, that's the same as writing 8 times 10 cubed times by itself, 8 times 10 cubed. 8 times 8 we can do. 10 cubed times 10 cubed is 10 to the power, don't forget we add these powers. Now you could think the answer is 64 times 10 to the power 6, but we know 64 is has a power of 10 in it, because 64 is 6.4 times 10. So that's the same as 6.4 times 10 times 10 to the 6. Well, 10 is 10 to the power 1, so the answer will be 6.4 times 10 to the power 7. Let's have a look at part C. It says, find the value of 7.6 times 10 to the power 5 plus 8.7 times 10 to the power 4. Now, you don't really need those brackets there, to be honest, but let's have a look. If this is difficult for you, then there's one way of doing it here. You can put it into ordinary numbers. So we can say 7.6 times 10 5 times, because that's what 10 to the power 5 means. It means timesing by 10 5 times. So we'd have 1, 2, 3, 4, 5. So that would be 760,000. And then add 8.7 times 10 4 times. 1, 2, 3, 4. So that'll be 87,000. Let's just get rid of this decimal point there. And then what we can do is we can just add them normally. So 760,000 and 87,000. So that's 847,000. So I can definitely see 8.47. And if I times that by 10 once, twice, 3 times, 4 times, 5 times, then that should be my answer. Question 8. 20 men, 10 women and 10 children are in a competition. It gives the mean score for the women, the mean score for the children, the mean score for everybody, and it asks you to work out the mean score for men. So what I've done here is I've put all the women from 1 to missed the ones instead of writing them all out. So I did 3 dots there to show the missing ones. So all of those 10 women divided by 10 gives 15.6. So the numerator here in this fraction is just going to be 156 because I've just got to times both sides by 10 in this equation. The same for the children, times by 10 again, gives me 92. Then I've got all the women, all the children, all the men, divided by a total of 40 is 11.2. Now this is a non-calculator paper, so you've got to do 11.2 times 40. So I guess one way of doing it is 11.2 times 4 times 10, and 11.2 times 10 times 4 is the same, which is just 112 times 4, which you can work out to be 448. So what we know is that the sum of all the women was 156. The sum of all the children is 92. And we've just got to work out the mean score for the men. So to do that, we just have to work out, well, how many men were there? Well, that's an unknown here, so we don't know that just now. But we know that 156 plus 92 plus what we're trying to find out is 448. So if we do 156 and 92, we get 248. So that means there has to be 200 men. So what will the mean for men be? Well, it should be 200 divided by, well, how many were there? 20, and that gives 10. So the mean for men is going to be 10. The next part says, Kevin was wrong. The mean for all 40 people was actually 11.5. Okay, well, let's have a look. If it was 11.5, then this number here would change, which means that if we times it up by the 40, it would be less than 448. So if we had less than 448 in total, what would that mean for the number of men? Well, these numbers remain unchanged, so it would mean there would be less men, so it would reduce the mean. And in brackets, just put still dividing by 20, you see, that's unchanged. Okay, so we've got less men, and that number, which is less, is still being divided by 20, which is going to reduce the mean. So definitely underline the word reduce. Question 9. The stem and leaf diagram shows the ages and years of 25 people. On the grid, we've got to draw a box plot for this information. So if we've got 25 bits of information, by the time we count to the halfway mark, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this will be the 13th. That will be the median. So if we count to the 13th in our stem and leaf diagram, and they're in order, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, then that means the median will be 28. So we can definitely put that bit in first. So let's put the median down as 20 or 28. So there we have it. And that's going to be our median. Our lowest bit of information in terms of age is 17 years. So we can put that in. And that's our lowest. And then the highest is 41. So we can put that in there. That's the highest. And then we want the lower quartile and the upper quartile. Well, the lower quartile, let's have a look. If we've got 12 bits of information to the left of the 13th piece, then we've got 12 bits of information. So we've got 1, 2, 3, 4, 5, 6 this way, and then 1, 2, 3, 4, 5, 6 this way. So that's the 6th piece of information, and that's the 7th piece. So we want to go in between the 6th and the 7th. So in our stem and leaf diagram, 1, 2, 3, 4, 5, 6. Notice I count from the inside out because they're in order of size. So 4, 5, 6. So it's between 22 and 24, which is 23. So that's our lower quartile, 23. Write that as LQ. And then our upper quartile, well, same principle here. 1, 2, 3, 4, 5, 6. So it's going to be between the 13, 14, 15, 16, 17, 18, the 19th and 20th piece. So let's count from there. So we've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19th and 20th. So it's between 32 and 33, and we take the median of that. So 32 and 33, the mean of that, so 32 and 33, that would be 32 and a half. So we've got 32 and a half here. So there's 33, there's 32, so 32 and a half. And that's going to be our upper quartile. And all I've got to do is just join these up to create my finished stem and leaf diagram. And of course, you're going to use a ruler in the exam. I'm doing this freehand. So let's just neaten that up a little bit. So there's our box plot for that information. It says, one of these people is chosen at random. What is the probability that this person is 30 years of age or older? Well, if we look back at the stem and leaf diagram, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people out of the total of 25 that were surveyed. So you can just leave that as a fraction, so the probability will be 10 25ths, or you can cancel it down, dividing the top by 5 and the bottom by 5, so 2/5. Let's have a look at the next part of the question now. So we can move that out of the way. It says the group frequency table gives information about the ages of a different group of people. Andrew, this cumulative frequency table for this information. The cumulative frequency table is not correct. Write down one thing that is wrong with the table. Well, interestingly, it's only the cumulative frequency table that is wrong. So this one is given as correct. So I would suggest that you have between 0 and 20 is 7, but then you'd have to write here as between 0 and 30 would be 7 and 12, which is 19, and then 0 and 40 up to and including would be 24, and then 0 and 50. So the class intervals need changing to the above. Question 10. The vector AB is given as 3, 2. So let's just check that is right. So AB, so 1, 2, 3 on the x and then 2 on the y, good. And we want BC to be drawn. And it says the rule is -1, then 4. So back 1 and then up 4. 1, 2, 3, 4. So we'd end up with C being drawn, draw the vector in, and that should be the answer. So for the next part it says AD is AB minus BC. Well, we're given AB and we want to take away BC. Well, that means it would be 3 take away -1, so that's 3 add 1, which is 4, and then 2 take away 4, that's -2 or -2. So AD is 4, -2. Well, let's have a look at that. So let's go along 4. So 1, 2, 3, 4, and then down 2. So that's where D would be just here. And if you want to see the vector A to D, that's what it would look like. But we're only asked to do a cross where D is. So there we go. There's our cross. Question 11. P is inversely proportional to the square root of m. So the square root of m would look like that, and if it was inversely proportional, then we'd have to do the reciprocal. Now what that means is there's a whole family of curves, and I think they would look something like this if you were to plot m versus p. If you want an inverse relationship, then it looks something like this. But if you square root m, it doesn't really make any difference to the shape of the curve. They will still have this type of shape. Okay, so there's a whole infinite set here, depending on the values of k. And you might ask, well, what does that mean? It doesn't have to be k. K is just some constant, which we can choose to satisfy this particular equation. Now, if k was 1, you might, for example, get this value, this curve here. If k was 2, you might get this one, and so on, and all the ones in between. But because we're given two values that the curve goes through, like a coordinate, that helps us find the particular value of k that is unique to that particular curve. So let's have a look. P is 10 in the question, and m is 1/4. Now the square root of 1/4 without a calculator is not too easy. That means something times something is 1/4. Well, 1/2 times 1/2 would be 1/4. So the square root of 1/4 is actually 1/2. So that gives us 10 is equal to k divided by 1/2. So the nice way out of trouble for this one, if you're not sure, is to just double top and bottom here, because they're make an equivalent fraction, and that would give us 2k over 1, which is just 2k. So that means 2k equals 10, so then k is 5. So once we have the value of k, we can put it into our formula here. So p is actually 5 over the square root of m. Now, we've got to work out the value of m when p is 2. So we put p as 2 in here. What we can do is we could square both sides if we wanted. We could then times both sides by m. And then we can divide both sides by 4. So m would be 25/4. If you want to decimalize that, then that's fine. That's just 6.25. Question 12. The region capital R, shown shaded in the diagram, is the region between two circles with the same centre. That's important, the same centre. The outer circle has a radius of 2n plus 6, and the inner circle has a radius of n minus 1. All measurements are in centimetres. Now it says the area of capital R. Well, let's have a look at that first. What is the area of capital R? Well, isn't it the area of the big circle? So pi times the radius squared. Take away the area of the small circle, so that's pi times n minus 1 all squared. And it's saying that the area is greater than the area of a circle with radius n plus 13. So it looks as though we've got to look at that inequality and somehow boil it down to some value where we can isolate the n term. So that shouldn't be too bad. So let's divide everything through by pi. Now pi is greater than 0, so that's not going to change the inequality sign. So we can divide everything by pi. And that's going to give us 2n plus 6 all squared minus n minus 1 all squared is greater than n plus 13 all squared. So we can use the difference of two squares here, or we can just multiply everything out for this side. So I'm just deliberating what to do. I think I'll use difference of two squares, so I'll have 2n plus 6 plus n minus 1, lots of 2n plus 6 minus n minus 1, using a squared. A squared minus b squared is always a plus b times a minus b. If you really don't like that, then just multiply the whole of the left-hand side out correctly, and then don't worry about it. So we're going to have 2n and n, that's 3n plus 5, times 2n minus n, which is n, and then 6 minus minus 1 is 7. And that just meant I had a little bit less to multiply out here than what I had to begin with. So I'm going to have 3n squared plus 21n plus 5n plus 35 is going to be greater than n plus 13 all squared, which is square the first, square the last, and multiply these two terms together and double. It's always the case. And then I've got taken n squared from both sides, that gives me 2n squared here. Simplify this to be 26n, and that's greater than 26n plus 169. Take 26n from both sides. Take 35 from both sides, so that's 2n squared is greater than, well, 169 minus 35. That's going to be 6 minus 3, that's 3, 134. Divide both sides by 2. So it's looking to me that n squared is greater than 67. Well, 8 squared, let's get that so you can see it. 8 squared is 64, and 9 squared is 81. And we want n squared to be more than 67, so it looks as though we'd have to have 9 as our least possible value of n, because that's the only one that's going to be squared that's going to be greater than 67. So n is 9 is the answer here. Out of guilt, I just did the expanding method as well, so you don't have to use difference of two squares, and that's the working out there, so you can just follow that if you wish. Okay, let's move on. Question 13. The graph shows the temperature, T degrees centigrade, of the coffee in a cup at time t minutes. We've got to find an estimate for the gradient of the graph at time 5 minutes. So if you look here at 5 minutes, we have to draw a tangent, so it can only touch the curve once at that particular point. Now there's multiple ways of doing this. This used to be on the old GCSE many years ago. Let's just draw a line first. So let's get the line here, and let's draw one in. So we've got to position it so it's going to be only touching the curve exactly once at that point. And I probably shouldn't have made the dot so big in blue because it makes it a bit harder, but let's give it a try. That's probably as best as I can do by just looking. So that's the first thing that we need to do. Then I suggest that I'll try and look at some units that I know. Now I'm going to try and draw a triangle, so I'm going to go with a bigger triangle than small because I'll decrease the error magnitude. So I'm going to look at the time here. So the axis goes up in ones, so I've got 5, let's say nearly 10 here. So let's go with something like 9.9. And here I've got, well, it goes up in 2s here. So I've got 10, 22, 24, 26, 28. So what's the gradient? Well, that means if I go along 1 unit, so I can divide this by 9.9, as long as I do the same to this, then I've scaled the triangle down sufficiently. So I'm really going back 1 unit, and then I'm going up 28 over 9.9. Well, what's 28 divided by 9.9? Well, that's going to be, and this is without a calculator, so I would probably go for something like 28 divided by 10, because I think 9.9 is too hard to do without a calculator. It's doable, you could do it by long division, but let's go with 28 over 10 then, and that is 2.8. But let's also remember that this gradient is negative because the line is downhill. Okay, so let's not miss out that sign. Now let's have a look back at what the question's wanting. So we have to move this out of the way, I'm afraid. So we managed to get our gradient. And let's write that in. That was minus 2.8. But what did we actually do to get that number? Well, didn't we do 28 divided by 10? And the 28 was the temperature in degrees centigrade, and the 10 was a time in minutes. So what we've found is that the gradient was looking at the temperature per time. So it was the rate of change of temperature per time. So that's the first thing that you can say. So you can say it's relating to the rate of change of temperature of the coffee, e.g. the rate of change of temperature, or that it cools at a rate of 3 degrees per minute, or you can say a rate of change at 5 minutes. So either of those things will be okay, and I'll just write those explanations underneath for you. So there's the explanations for you. We've got rate of change of the temperature of the coffee, e.g. a rate of change of temperature, or cools at a rate of, and you can say 3 because it's just a rough estimate, you can put 2.8 in there if you want, a rate of 3 degrees per minute, or a rate of change at 5 minutes because it was at the 5-minute mark. And the mark scheme does allow anywhere between negative 3.5 and negative 2.5. Okay, so anywhere in that interval, and it's probably going to be an interval where it's allowed to be those values. So we'll just go with something like so. So anywhere between negative 3.5 and negative 2.5 inclusive. Question 14. Very, very difficult question to explain. There's so many different ways of looking at it. You could argue that if you wrote this quadratic in this form like so, with this value being your A value, B and C, then your line of symmetry is minus B, which is minus 80 over 2A. 2 lots of minus 5, that's minus 10. So you get your line of symmetry at 8, and therefore when t is 8, you can then work out the greatest displacement here, distance s. So you could say s of 8 would be 80 times 8 minus 5 times 8 squared, which is 640 minus 5 times 64, which is 640 minus 320, which is 320 meters. Are you using enough algebra there? I don't know, because it does say use algebra. I guess I've used some, so I could argue that could be correct. An alternative way would be to write s equals 80t minus 5t squared. Rearrange that to be minus 5t squared plus 80t. Then you could take this part here and say, right, okay, I'm going to complete the square. So I'm going to take minus 5 out, or negative 5 out as a factor. So I'd have minus here, because minus times minus gives the plus, and that would be 16t. Then I can complete the square. So there you go, I'm completing a square now. There it is. And then I've got to take away 64 from that to make it work. However, you've been taught completing the square may be different, so I'm not going to explain in massive detail how to complete the square. That's just the form that it is. How you got there is up to how your teacher has taught you, or you may have taught yourself. In this situation, we want to find the maximum on this graph. And to find the maximum, we want the maximum that this expression can actually be. Now, the only variable in it is t. So you can try making t a huge number if you want, but that's not going to work, because if you make this a huge number and just take away 8 and then square that huge number, you're not going to get the maximum it can be. You'll always get the maximum, as it turns out, when the bracket that you've made in completing the square is 0. That's always the case. Now, the only way of doing that here is to say, well, t must be 8, because then 8, take away this 8, is 0 squared, which is 0. Then all you're left with, and this is the lovely part about how this works, you've got negative 5 times negative 64, which is 320 meters. So that's a way that's acceptable, because I've looked on the mark scheme. The first method doesn't seem to be on the mark scheme, but the second method is. Alternative methods seem to say you can sketch the graph loosely and then see that you'd get 8 as your turning point. Okay, not massively rigorous. Another way is to just say that you've got s equals 80t minus 5t squared. If you factorise that, you can take out a 5t, and that will give you 16 minus t. And then the solution points here would be when t equals 0 or t equals 16, which would allow you to know this point, but interestingly enough, you'd know this point, and then using symmetry, you could deduce that t is 8, and then go this method to get 320 meters. So that's the best explanation I can give of that question right now. The interesting thing I've just noticed is that it does say this is between 0 and 16 here. So I guess the last thing I just said here, you're going to have to maybe plug in some values. So if you deduce that t equals 8 was the critical value, then you can put 7 into this expression, put 9 into that expression, and they won't be as high as when you put 8 into it. So I guess that's the extra rigour you would need. Question 15. There are only n red balls and n plus 1 blue ones in a bag, and Shamsa takes at random 2 balls from the bag. Show the probability that both of them are the same colour. And we've got to show that the probability of them being the same colour, rather, is n over 2n plus 1. So let's draw a quick tree. It won't take too long. So we want to have, say, first choice here could be red or then blue, and the second choice, depending on the first choice, could be red blue, red, blue. So let's write the probabilities in. Choosing a red first, well, there's n red ones, so there's n choices, but how many in the bag are altogether? Well, it's n plus 1, which is just 2n plus 1. But choosing a red again, well, there won't be as many reds now. There'd be one less than n, so there'll be n minus 1 to choose from, but there'll be less in the bag still, won't there? Because you've already chosen one to start with, so there won't be 2n plus 1 altogether. There'll just be 2n here. But let's look at the probability for blue. Well, it's going to be out of 2n still, but how many blues were there? n plus 1. But that's not necessary because the question says the probability that both of them are the same colour. So we only really want to have this root through here, and we just want this one here. So let's go straight to that. So blue to begin with would be n plus 1 over, well, how many? 2n plus 1. And then only n after you've chosen one of the blues out of 2n. So let's have a look at what we need. So we need this outcome here, which is n over 2n plus 1 times by n minus 1 over 2n. Let's bracket all of this off. And then what we have here is n plus 1 over 2n plus 1 times by n over 2n. Well, it looks like the denominators are the same, and that's good. So we're going to add these outcomes together. So we're going to have 2n plus 1 lots of 2n for the denominator. And then on top we're going to have n lots of n minus 1 and n lots of n plus 1, or n plus 1 lots of n, same thing. So our denominator, just going to neaten this up. You didn't really need these brackets here, only because you put the 2n at the very end. If you put it at the beginning, this would be fine. Now let's have a look at this. N squared minus n plus n squared plus n. Well, minus n plus n cancels, and n squared is just 2n squared. We're nearly there because 2 divided by 2 is 1, and now we've got to look at what n squared divided by n is. Well, if you think about it, n squared divided by n is just n. So our answer would be n over 2n plus 1. Question 16. There are two solid spheres A and B. A is made of gold and B is made of silver. Sphere A has radius 2 centimeters and B radius 3. It tells you the density of gold, it tells you the density of silver. We've got to work out which one has the greater mass. Well, density is how much mass you have per given volume. So if we multiply both sides of that equation by V, we'll have density times volume is mass. All we've got to do is work out the volume for each of those spheres, plug in the values and see which has the bigger mass. And luckily we're given the volume of a sphere. So for sphere A, the volume is going to be 4/3 times pi times the radius cubed. For B, the volume is going to be 4/3 times pi times 3 cubed. So that's going to give us 4 pi times 8 over 3. And this one's going to give us 4 pi times 27 over 3. So this one here will give us 32 pi over 3. And this one will give us, well, 3's into 27 is 9. I should have recognised that from here. So that gives us 36 pi. Now, we already know that the mass is density times volume. So if we create a little bit more space for ourselves here, then what we can do is we can just do some calculations. So the mass for sphere A is going to be its density, which is, now that's made of gold, so it's going to be 19,000 times, well, how many meter? Wow, it's in meter cubes. So we've got to be really careful because the radius was given in centimeter cubes. So what we should do is, how many centimeters are there in a meter? Well, there's 100. So as we've got a volume, we've got 100 in 3 directions. So if you think of a volume of a cube, if we wanted to compare 1 centimetre cube to a whole metre cube, then what scale factor are we going to be using? Well, if there's 100 each way, we've got 100 by 100 by 100. So that's going to be 100 times 100 times 100, which is going to have 6 zeros. So it's going to be a millionth less than what we've already got. So we've got the density, so we've got 19,000, but then we've got to convert this volume, and that's in centimetre cubes, so that will be 32 pi over 3, but then I've got to make it a million times smaller. So these will cancel here. Don't forget this is a non-calculator paper. So they're gone, and we're left with 19 times 32 pi over 3,000. Well, 19 times 32, well, 20 times 32 is 640, and we've just got one lot of 32 to take away, so that's 608. So that gives us 608 pi over 3,000, and I can cancel that down later. Let's look at mass of sphere B. Well, it's going to be 10,000, and that's kilograms per metre cube. Now don't forget the volume here was 36 pi centimetre cubes, so I've got to divide that by 1 million. So 1, 2, 3, 4, 1, 2, 3, 4. So we're left with 36 pi over 100. So let's compare these now. So a bit more space. And we shouldn't be too far off an answer now. So this one cancels down to 304 out of 1,500 pi, which is 152 out of 750 pi, which is 76 out of 375 pi. And this one here is going to be 18 pi over 50, which is 9 pi over 25. Now, I'm probably going to get loads of complaints for the way I've done this question, but if you kind of compare 9 pi over 25 with 76 pi over 375, well, how many 25s go into 375? Well, that's going to be 4, 8, 12, 13, that's going to be 15 of them, isn't it? So if you times that by 15 and that by 15, you're going to get this one out of 375. And what's 9 15s? It's 90 and 45, which is 135 pi. So this was for B, and this one was for A. So can you see that B is going to have a greater mass because it's got 135 375ths of pi, whereas A only had 76 pi over 375. So I would say sphere B. Now I'm going to have a look at this question again and see whether I can explain it in maybe a slightly simpler way, because there just isn't a calculator, so there's got to be another way of doing this a little bit more simply. And I've seen a way just by looking offline for a bit. I've just compared these. If I looked at these two situations here, well, if I times this bottom one by 30, I'd have to do the same to the top. And then what I'd get from this one is, if I just put a circle around this one here and create some space at the top here, I'd have 3 times 36, which is 108, so I'd have 1080 pi over 3000. Then I've got the denominators to match a lot more quickly than I did before. So we'd get 1080 pi versus only 608 pi for sphere A. So again, you can say sphere B. If you've got a better way, then please just message and let me know. Okay, and I'll put your message up on the message board. Okay, thanks. Question 17. We're given x squared minus 9y squared equals 0. And we're also given that x is greater than 0 and y is greater than 0. Well, we could look at this as difference of two squares because it's x squared minus 3y all squared. And that's the same as x plus 3y times x minus 3y. This would give us x equals minus 3y, and this would give us x equals 3y. Well, let's have a look at part B. We'll start with the denominator, I think. So we'll leave this one here, the numerator, for now. And we're going to factorise that and hope that we get two nice brackets. So we're going to have a 2x and an x, factors of 3, 3 and 1. We want to have negative 7x, so we're going to have positive 6x. In fact, we're going to have negative 6x, isn't it? So negative 6x, and then take one more away, and that would be negative 7x. So we're going to have 2x minus 1 and x minus 3 as the denominator. And then for the numerator, if you don't like the look of how that is and you want the x squareds in front, well, just write them this way. That's absolutely fine. And then what you can do is you can take negative 1 out as a factor here. Notice the signs changing here. Be very careful. And then what you're hoping for is that the numerator here, this bracket here, will decompose into two brackets where you may see a 2x minus 1 or an x minus 3. That's what you'll be hoping for, then one of them would cancel. So two brackets here. Well, let's have a look. We'd have factors of 4x squared, or just factors of 4, coefficients of coefficient being 4. Well, I'm going to go for 2x and 2x because I'm hedging my bets here. And then I need factors of 3, so I'm going to put a 3 here and a 1 here. And then what I'm going to try and do is I'm going to try and force and see if that would work because I've got a 2x minus 1 underneath. So I'd have 6 at x minus 2x, good. That gives me the 4x that I wanted here, positive 4x, not negative 4x. And so I wanted a negative 3 here, so this would have to be positive. And then I've got the desired outcome I wanted. These cancel. And so I'm left with 2x plus 3 over x minus 3. Now, this may be of some confusion to some people, but let's have a look. Hopefully you'll understand this. Let's look at this number here, negative 1. And there are many ways of getting negative 1. This is one of them. 1 divided by negative 1 is still negative 1. And this part of the numerator stays the same. But if I write x minus 3 underneath and I multiply this out, it's going to give me 2x plus 3 on top because that's just one lot of whatever I've got in here. But then, can you see this gives me minus x and this gives me plus 3. Now you might think, well, that's a bit messy, but the mark scheme would say this, more than like. Okay, so this is fine. The other outcomes would be fine also, you'd get full marks for those, but this would be the a most concise way of writing the answer. Question 18. The graph of y equals f of x is shown on the grid. On the grid, sketch the graph of y equals f of x minus 1. Well, we should know that f of x plus a, that's the translation parallel to the x-axis, and if we have f of x minus 1, we basically do the opposite to what's in the brackets. So we push it forwards, or we translate it to the right 1 unit. So this would look exactly the same apart from everything is moved along 1. So it says on the grid, sketch that graph. So let's do that one first. So there we have it there. And then the graph of y equals f of x has a turning point at the point negative 1, 1. As shown here, it's the maximum. It says write down the coordinates of the turning point of the graph y equals f of minus x plus 2. Well, without going to massive explanations here, if you just take your maximum point, what we have to do is, here we're saying that the values of x become negative, so this would change to positive 1. I'll just write that there to emphasize. And then y as a total has increased by 2. So we can just write 1, 3. Question 19. 1 plus root 2 divided by 3 minus root 2 all squared can be written in the form a plus b root 2. We've just got to find the values of a and b to make that work. Well, let's try our best to see what we can do. So let's do the denominator first. That's 3 minus root 2 times itself. So we're going to get 9. We're going to get a minus here times a minus, which is plus, and root 2 times root 2 is just 2. And then we're going to have 3 times minus root 2, which is minus 3 root 2. And then 3 times minus root 2, which is minus 3 root 2 here. So the nice numbers is going to be 9 and 2 is 11. And then we've got minus 3 root 2, minus 3 more. So that's minus 6 root 2. And the numerator stays the same. So we've got some of the way there. Now we've got to rationalise the denominator. And the only way of doing that is to multiply top and bottom by the conjugate of 11 minus 6 root 2. Don't worry about the word conjugate, you just do the opposite sign because you're looking for, and hopefully when you've been taught at school your teacher's told you about the difference of two squares, and that is if you have something like underneath 11 minus 6 root 2, if you times it by 11 plus 6 root 2, then you're not going to have any square roots when you multiply the answer out. Because when you have a squared minus b squared, it's always written as, and can be written as, a plus b times a minus b. So just give that a try, it will always work. So let's have a look at the denominator. Well, we know what that is. That's just going to be this number times this number minus this number times itself. And you might think, well, hold on a minute, why is that the case? Well, I've just explained about this a plus b and a minus b business. If we took our a to be 11 and our b to be 6 root 2, then we'd have the form something squared minus something squared, i.e. a difference of two squares. Now, let's have a look. So we're saying that this is going to be our a in this case, this is going to be our b, so we've got a minus b. And then this is our a still, and we've got, this is our b. So we do have a minus b times a plus b, which is a squared, so 11 squared is 121, minus b squared. Well, 6 root 2 times 6 root 2, what's that going to be? Well, 6 times 6 is 36. And then root 2 times itself is just 2, so that's going to be 72. So the denominator is going to be 121 minus 72. Now let's have a look at the numerator. Let's multiply that out. So we're going to have 11 plus 6 root 2 plus 11 root 2. And be careful here, plus times a plus is plus, and then root 2 times 6 root 2 is 6 times 2, which is 12. Oops, wrong side here. Now we can simplify this part here because I've got 6 root 2 and 11 root 2. So that would give 11 plus this 12 here, plus, well, what is 6 root 2 and 11 root 2? 17 root 2. And 121 minus 72 on the denominator. Well, 121 minus 72, from 72 to 100 is 28, and 21, that's 49. And then what I have here is 11 and 12, that's 23. And then plus 17 root 2 all over 49. Now this looks quite difficult, I have to say. I mean, to doubt my answers. I did just look at the mark scheme and it is right, but I would doubt myself in an exam because the numbers are quite difficult. You can split that up as this, which will enable you to find A, because A is just going to be 23/49ths. And B is how many of the root 2's I have, which is 17/49ths. So not an easy question there. So I would give surds and rationalise in the denominator a good load of practice if I was you, because it's so easy to make a mistake in these types of questions. Question 20. Well, this is an interesting question. I've not seen a question like this for a very long time, if at all. If you look at the first triangle here, you can see it's right-angled and it has an angle of 30, an angle of 90, and another angle, which must be 60, because angles in a triangle make 180. But if you look at the second triangle, can you see that it has the same angles? A 90, a 30, and a 60. And so does the third one. So that means the first one and the third one must be similar, which means that if you take the value y, hasn't that got to be the same as n with a scale factor of enlargement? We've just got to find the value of k in this case. So let's have a look. Let's call this triangle 3. Now, these are all 60 in their degrees. So I'm just having a think here. I don't usually get stuck too quick, but I'm just going to have a think. If I was to call this x here, then I think what I can do is, if I can work out what this length is here, I can then compare x here with what I've got here, and that will give me the scale factor of enlargement, and that will be the same scale factor of enlargement between y and n, or they wouldn't be the same, or they wouldn't be similar right-angled triangles. So in triangle 1, I will use the fact that I know all the angles here, so I can use sine, cos, or tan. It doesn't really matter. I think I'm going to use opposite and adjacent. So I'm going to say tan 60 equals x over y. Now, tan 60 is root 3. So root 3 equals x over y, which means x is y root 3. Okay, so that's y root 3. In the second triangle, then all I need to do is find this length here, and I can do that in the first triangle because I know that by Pythagoras, if I square this length here and add it to the square of this length, now y root 3 times y root 3 is 3y squared, and if I square root that, that will give me, well, what's y squared plus 3y squared? Well, that's 4y squared, so the square root of 4y squared must be 2y. So that's the length of the hypotenuse in triangle 1, which then becomes one of the other sides in triangle 2. But in triangle 2, I can just repeat the process. So let's have a look. I can say, well, I want this desired length here, don't I? So can I not say that I've got opposite and hypotenuse? Now, opposite and hypotenuse is sine, so that means the sine of 60 equals the opposite, which is 2y, over the hypotenuse, which is what I want. But what is the sine of 60? The sine of 60 is the cos of 30, which is root 3 over 2. So I can rearrange for the side that I want. So I can invert both sides, or I can just times both sides by the tick, and I would get, and then times both sides by the 2, and then divide by the root 3. So let's have a look what we've got. Now, I guess it was a bit silly to call it a tick, but it doesn't really matter, just use it as a symbol, it's fine. And we know that's 4y over root 3. And we wanted it in terms of this number here, x, remember? Because we wanted to see what scale factor of x it turned out to be. Well, we do know something linking y and x, that's really good news. So we know from here that if we divide both sides by root 3, that's what y is, and we can substitute that in here. So we know our missing length is 4 lots of what y is, and y is x over root 3, divided by root 3. So that means our hidden length that we wanted is 4x over 3. Well, that must mean that our scale factor then is 4/3, because if we had, and I'll just go back to my original diagram, if I had this value here as x, and then I'd worked out that this was 4/3 of x, doesn't it mean that I times x by 4/3 to get the larger triangle? Therefore, I'd have to do the same here, and that would be y times 4/3 gives n. So let's have a look. Does that work? So y times 4/3 equals n. Well, let's get that as y on its own. So let's times both sides by 3 and divide both sides by 4. So yes, y is 3/4 n. So I don't think I explained that in the best way possible, really. I think if I was to do that again, I would probably use sine and cosine instead. So I will just do this question one more time, a different way. If you don't like this question, and you understood it first time rather, just skip forward to the next question. So here we have our question again. Let's do it a different way. Let's call this length x, and we'll just try and work out what this length is here without calling it a symbol at all. So in the first triangle here, what's our relationship between the y, x and the angle 30? Well, we can have opposite and adjacent, so we can have tan. So we can have tan 30 equals y over x. So tan of 30 is root 3 over 3 equals y over x. So from that, we can times both sides by x, and that will give us y equals x root 3 over 3. So that's something that's quite important here. So we can call that x root 3 over 3. Now, looking at Pythagoras, we can find this length here. So we'd have to square this value here, so that would be x squared. Square this value here, so be careful. We'd have 3x squared over 9, which cancels down to x squared over 3. But what is x squared plus x squared over 3, well, look at it this way. It's like 3/3 plus another third, which is 4/3 of x squared. But then we'd have to square root, isn't it? Because it's this squared plus this squared is this squared in terms of the area, but to find the length we have to square root at the end, don't we? So we'd end up with 2x over root 3. We can just leave it like that, that's fine. So this is 2x over root 3. Now, if we look in the second right-angled triangle, then what can we do here? Well, we can link what we wanted here. So what we shall call it now is, we'll call it a proper letter, and we'll call it, say, P. And let's use the angle of 30. So we've got adjacent and hypotenuse. So that means cos of 30 is the adjacent, which is what we've just found, 2x over root 3, over the hypotenuse, which is P. Well, let's have a look what that is. The cosine of 30 is the sine of 60, which is root 3 over 2. Here we have 2x over root 3 divided by P. Now, if you don't like the look of that, then that's okay. Just times this by root 3 and times this by root 3, because there'll be an equivalent fraction. And then the nice thing about this is this cancels, and we're left with root 3 over 2 equals 2x over P root 3. What you can now do is you can times both sides by P, times both sides by 2, and then divide both sides by root 3. Now, what have you got left? You'll have P equals 4x over root 3 times root 3 is 3. So P is 4x over 3. Now here's what you do. You compare this number here with this number here. So we started off as x in the smaller triangle, and we got 4/3 bigger. So the scale factor must be the same for y. If we times y by the same scale factor, we must get n. So we take y here, multiply it by the same scale factor, 4/3, and that would give us n. And then don't forget the question said, can you prove that y is 3/4 n? Well, we can, because from here we can get to here, can't we? Because if we times both sides by 3 and then divide both sides by 4, we get the required result, y equals 3/4 of n, or 3n over 4. There are plenty of other ways of doing that question. Maybe give it a try doing it a different way.